How's my hair? We are going to test C4 Camelots from Black Diamond today.
Oh, the head came out!
These are pretty damn light, but these are just called C4 Camelots. They have an ultralight version, which instead of a steel cable in the handle, they have Dyneema, which I think is pretty cool. Now, this is crimped up here at the neck, where the cable comes up here, but the Dyneema is spliced here at the bottom, and then it loops over a pin at the top. It doesn't have quite the bend radius I think Dyneema normally likes to have, but obviously they're super good enough. Black Diamond's putting them out.
Yeah, that's generally our goal, super good enough.
The issue is, they're saying there's a 5 to 7 year expiration date on the Ultralights, because obviously time isn't going to do a lot to this if it's stored properly, except for the nylon sling, which you can actually re-sling them. After 10 or 20 years, you can replace these and make this super good enough. But you can't really re-sling the Ultralights because it's all kind of integrated inside. But I don't know how to break these up here because I'm on top of Prusik Peak. And all I have is about a half a bottle of water left in these two cams. So let's go to the lab. There is a 0.5 Black Diamond cam. Oh, he lost his helmet. How sad. Yeah, Cam Crusher's solid, baby, and so is that cam. The peak force was 10.56. Let's see what this breaks at. 3, 2, 1. 3, 2, 1. $14.52. It popped. There's no sling.
Broke the sling.
We're at right where the cable would be.
We're doing the 0.75 again. No sling. Does that look familiar? Yeah, I thought so. That's where they normally break. Wires don't like pinch points, and a carabiner is a pinch point. It's at a force you're never gonna get. So if you have a good placement, it's probably super good enough. Oh, this is seized shut, man. That is what I would call tipped out. This doesn't function. The trigger does not work at all. Oh my God! It came out of the head!
This is the Dyneema stem. And you can see in there, I think that's a 12 grade ultra high molecular density polyethylene.
Crushed the edge of the tips and actually started to move the lobes that were seized. And that's just the plastic trigger for those wires. All of that stem is gone.
So we got the stem and there's a little pin in there. Hope you can see it. And it looks like this was wrapped around that somehow, and that's what secured it in there. And that's super strong for a cam.
So this is rusted, but it still works. So right now all my weight is on this. I'm bounce testing it.
12.66.
Another decapitation one.
So I think I figured out how they make these. Is there's a little pin inside of here, and I think they just make a loop with the Dyneema. It's a small bend radius. I'm surprised we're not getting lower results. So here's a number 3 Black Diamond. Three, two, one. Holy shit! Whoa.
Boy, that was messing up the rock.
That is
It
mangled.
literally flattened out.
Messed up the cam, busted the rock.
I mean, that's just such good thumbnail material.
This is a old Camelot 3.5. This is our new ultralight one. This is actually used to be my cam. I marked it with green nail polish.
Because that's original.
And I stopped, well, Ryan copied me on that. And I stopped using it because there was this much flex in it. But you'll notice these lobes all buckled. And I'm curious if these, which have a lot more material there, will not do the same thing and we'll get a better result.
Matt asked if they break dynamically or statically in the lab to get those numbers.
Can somebody from Black Diamond tell us that?
Do cams get rated based on a very static, engineer driven built test, or is it like dynamically loaded with their weight in a track system. Like, we don't have a track for our weight to fall into, so there's variables on whether or not it's turned or twisted or spinning.
But that shouldn't affect the ultimate force.
But that's how I fall. So
Yeah.
I don't mind. I like what I have.
Yeah.
But how do they generate that number? Compare apples to apples. I think engineers create a very sterile, perfect environment in order to give us those numbers, which is probably what you need to do to compare two different products. I'm gonna go compare a product right now. There's our 3.5 Camelot with a soft shackle in the eye. I just do not think that's coming out. The head came out! That is a different result.
Okay, so we had failure there, and it released and just shot out of the top of the cam crusher. Wow!
What?
Yes,
20 something.
22.71.
I retired this because I was worried about the cams flexing back and forth and the nylon sling getting old. It turns out this is the strongest cam we've ever tested.
So on my way to Moab here, I thought, why not hit up Black Diamond and ask them about the Ultralight directly? And I just sent an email to their general inbox, and within a few days, I was talking to the people who helped design it. The next part of this video is an interview in the lab of Black Diamond and getting to break one of the Ultralights in their machine. I've made it. I got to touch one of these. Is this a number 20?
21.
21. And this is for your standard offset chimneys.
Yeah, totally.
Okay.
One of a kind. I'm Jeremy Steck, a design engineer. I've been here for 11 years.
Alex Baker, same job. 1 year less than him.
Did Black Diamond come to you and be like, we want an iPhone that does something nothing's ever been done before? Or was this a personal project that turned into a product?
That one was probably closer to like a personal project that turned into a product. We're always like screwing around with like lots of different things. And if something ends up kind of looking cool enough, then we start to integrate it into like the larger like standard system. But this one was more like come up with this idea, and then once we saw the idea, it was like, okay, we should try to commercialize that idea. It wasn't like, there wasn't someone that was like, we mandate
very
like,
ambitious manager.
yeah, exactly.
You made the lobes lighter, the wires lighter. This is made out of Dyneema. These cost more money. Is that because it took so much money to develop, or does it cost more money to like hand splice this stuff, and because you're not just pinching a cable with a machine up here?
The cost is probably more related to the assembly process than the actual materials involved.
Yeah.
Because even if this was the most expensive, let's say, Dyneema out there, it's still only a couple bucks worth of actual material.
Yeah, the Dyneema itself, like material-wise, is
Like this is
not that
nothing.
much.
This is nothing, especially at the scale you guys buy.
Yeah.
But I don't know an automatic splicing machine out there.
Yeah.
Unfortunately, we don't either.
I think from like our first time like actually screwing around in the lab to it being on shelves was probably like 3 years, something like that, which is pretty normal. Yeah, and yeah, maybe even arguably a little bit short, but you can see that the Dyneema, it does have to twist 90 degrees as it comes through here so that it can wrap around this little rivet up here.
Yeah.
And then it's spliced at the bottom. So it's really just a loop of Dyneema. That's it.
Now, the rule is you're supposed to have a big ass bend radius for any textile that get full strength. And you're not getting full strength out of its full potential, but it's so strong you don't have to, right?
Yeah. Yeah, I mean, full strength is, there's probably an ASTM test or something where it's wrapped around a large drum. So
Yeah.
But, we don't even come close to that, so.
And you don't need to, though.
No, we don't need to because, I don't know, what's the rating on this thing? It's probably like
12?
10 or 12 kN. It probably breaks in the 15 range most of the time.
Yeah, I was getting above 12, and spoiler alert, the ones I broke was in a house fire. So they were old and in a house fire. Not in the actual fire, but just the water damage, the heat, and Dyneema doesn't like heat. Now, you said you've tested this in cars in Mexico?
Yeah, because Dyneema has a very low melting temperature. We needed to make sure that that wasn't going to be an issue. And I think the worst case scenario we came up with was like if you put it on the dash of your car in the hot sun when it's super hot out for a long time. So we, you know, at one point we put little data loggers in there and sent them to Mexico. What is interesting is you can bring it quite close to its melting point and then it's actually like still full strength.
It's great until it's not.
Yeah, exactly. Yeah.
Now you have a conservative expiration date on here.
We don't know for sure, and we like how long this thing can sit around and then become not usable for all sorts of reasons. It might be that it's like not strong enough anymore, but it also could be that it just like won't retract or like maybe the triggers fall apart or something like that. But
because the triggers are smaller too. On this.
yeah. And so the reality is we have to choose some sort of estimate for when we think the thing is going to expire. And I don't know exactly what we put in the instructions, but that's our best estimate, and it's probably a little bit conservative, but there's also probably some good reasons for it, you know, like if you do end up, if it is in a super hot environment or exposed to water or salt and all these sorts of things, you know, you have to be pretty confident that it's still going to be good if you're going to write it in the instructions.
Yeah, if you're putting it officially in the paperwork.
Yeah. If you look at our test plan for cams, there's like the CE stuff up here,
yeah,
and then there's like that's like 10% of it probably.
Gotcha.
And there's all this other shit, especially fatigue testing and environmental testing.
Because you'll cyclically load this as well, right?
Yeah.
Yep. You'll throw it in hot cars, you'll go out and use it.
Yeah.
So
put it in ice, water, various other crack configurations.
Yeah, some stuff that looks like CE tests, but we put it in the jig in very weird ways, maybe over some edges.
Yeah. Redesigning something that already exists, did this take you nearly as much work as something that's very different?
Well, that one's a little tricky because, you know, to be frank, the brief was, don't fuck it up.
Yeah.
You know, because this is like everybody's favorite cam, and we're going to try to make it a little bit sweeter. Oftentimes people get greedy, and then you ruin it. Yeah. So I'd say it was tricky because we had a lot of ideas, but we were like, you know, there was a lot of ideas that kind of were left, you know, on the shelf with those because we're like, that might be too much for this round, or we're a little uncertain, or users might not appreciate this. So we had to kind of weigh that. In fact, the product changed even through field testing a little bit.
You don't want to change the formula of Coke after 100 years?
And even just handing people samples of the new ones, immediately people were like already kind of like, I don't really want a new one. We had some black lobes on there in the middle instead of, they used to always be silver in the middle.
Yeah.
And that was a problem. People didn't like that.
When does this become standard?
Oh my God. Just making that one was so hard.
Well, is it because you have to hand make it because you only made one?
Yeah, that's mostly it.
Gotcha.
And it needed to look good.
Yeah, pulling on the trigger, you have to have Alex Honnold's strength just to pull this thing. When's the number 6 and 7, or 7 and 8 come back out?
They're being built now.
Are they? Okay, because everyone wants them.
I know. I thought we've been building them all along, and people keep asking me about them.
Yeah.
Apparently, we haven't, for whatever reason, we haven't built them. But they are for sure. Like I just consulted with guys like last week about it. Like they're on the list in the next like week or two.
Because you know the standard picture where it goes all the way to number 8.
Yeah.
We put that on Extreme Gear store, and everyone flooded to it for the big ones, thinking they were in there. It's like, no, actually they're sold out like everywhere else. You didn't make the Ultralight for what, the 5 and 6? Because the weight of the stem to the rest of it doesn't save enough weight to justify that.
Yeah, if we were to do we could have put this light stem on the 5 and 6, but the weight savings would have been fairly minimal. Even though it seems like it should have been more, it really wouldn't have been that much. All the weight savings would be more up
if you
here,
could do something with the head.
Yeah, Jeremy just did the 5 and the 6, and I'm sure it's way lighter than the old 5 and 6.
I think it's just a percentage game, though. Like, I mean, you definitely would save some weight by taking out the steel cable and all that stuff, but it's by percent of the cam. It's a low percent number.
From, would you go all the way down to 0.4 or?
0.4 is the smallest.
0.4 to
on the
number
Ultralight?
4 on the Ultralights.
Yeah, we brought the point.
It was a 0.3.
We never sold it, but we came this close.
Now, are these for funsies, or is this the newest and latest in flex stems?
Yeah, dude.
Unless there's demand, you know, maybe people want that. Got a curve to the left.
Is that the reach around?
I mean, we have a team for every project. We have guys that are good at a variety of things. We have industrial designers. They're the guys that get the ergonomics right. You know, that sort of thing. You know, just visually making it look appealing. You know, we're kind of like the guys that make stuff work. You know, oftentimes making it ugly. They're, you know, so it's a back and forth between the ID guys. We have QA guys that sit in. They're the guys that do the testing and also make recommendations. You know, that things need to be stronger, or maybe statistically it's not strong enough, like that kind of thing. We have manufacturing engineers. We got, you know, everybody's in there, like marketing, sales. I mean, everybody's kind of a part of the team.
I just love that like the QA guys are gonna see me touching the Instron. Surprised there's no one coming running right now.
Man, a brake test machine in a climate-controlled environment. How exciting. This machine, whoa.
Let's see here. There, it still works. When brake detection went off, it stops pulling, so we could now just rip it apart and see.
Is that a setting, or is that
It's a setting.
It's a sensitivity, yeah.
Gotcha. This is an interesting thing, is the neural biting the teeth.
And you can see when you get to those kind of loads, this kind of flattens out a little bit.
watching that.
Yeah.
There we go. There it is. Typical.
It's just plastic, right? Technically, the rope's plastic.
Yeah, the whole thing's plastic. Yeah.
But that's the pin.
You can pull this guy apart and look at this a little more if you wanted to. It's usually kind of stuck in there. The very standard Chinese finger trap style. One goes in the other.
Gotcha.
Goes in the other one.
I like the
We did it
stitch,
one
too.
time, and then we stitched it.
And the stitching doesn't hold the force, the stitching keeps it from coming undone.
Yeah,
in
it
the
would
cyclic.
be full strength for sure one time without the stitching. But if you want it to be able to hold thousands and thousands of loads, it'll come apart if you don't stitch it. So you can't really like separate the design from the process of this particular product. So, you know, the design and the assembly process really had to evolve together on this one. So the normal production team was like very involved in the design of this thing. And there's no way that it could have like came together without the ability to work like directly with a good production team. Otherwise it'd be like, if you try to just hand this off to someone and be like, go
make
build
a lot of
this.
these.
Yeah, no.
That's impossible.
Were you guys Dyneema nerds before this?
No, not at all.
So.
We like, you know, went to YouTube and Googled how to splice and then got a pen out, and it probably took us like 45 minutes to make our first splice, you know, because we didn't understand it and we didn't know how to do it. And then just spiraled completely out of control from there.
And you guys basically just started making loops, right?
I think the very first thing we did is we just like made a loop and we're like, is this really going to be as strong as they say it is? And then it was, and you're like,
It is. If
All
you've
right,
never
what's the
touched
next
it,
step?
and then you do that, you are like, you realize the possibilities are pretty crazy with Dyneema.
yeah, especially because we weren't stitching them then too. So like you've got this thing that holds 20 kilonewtons you can take apart with your fingers in like a second.
Yeah.
And put back together, you know. And then the UV is important for the coating. And then for this particular product, we had to specially develop the tube. This isn't like off-the-shelf tubing either, to be able to get something that fits through nicely and provides the UV protection that you want over time.
They're super good enough. You want to say super good enough on camera, or is that not legal?
Super good enough.
You have
I
to
think I
talk
already
to
said
legal.
it. Yeah,
Super good enough.
that's generally our goal, super good enough.
You can imagine how much fun it was for me to see other people's brake test machines and get to nerd out with other nerds on gear. So now we'll break just a few old Camelots in our slow slack snap machine. Oh, that's a cool result.
That is shocking that this did not get cut, especially when you see the force.
Oh, that's amazing.
Oh, never mind. They're right. It just is different than a C4 or a modern C4.
A modern C4, yeah.
This thing didn't break. It was doubled up, and this cable broke.
Still completely functional.
Completely.
Besides that,
Tins high enough to have damaged the lobes or axle.
I think it got damaged on the carabiner. This was hiding like here,
Yeah.
Yeah.
Well, it is damaged. I'm not saying it's in great shape.
but this was a carabiner, not that sharp. It's protected by
Unless it
plastic.
flipped. It could have
It
flipped.
could have flipped. So this is a Camelot number 1, and most people, like myself, thought only Black Diamond made Camelots. This is a Chenard Camelot, which I didn't know was a thing, and I think is very, very sad and wrong that we're thinking about breaking it.
We're gonna break it.
Very cool piece of climbing protection history here.
So this completely like slipped and came through, which means the axle's completely jacked probably. And then this cable was the final grand finale, which is what I'm expecting out of quote unquote full strength.
Actually,
Whoa, it's
that
still
looks very functional.
So it slipped at 11 and then the wire broke at 11. Weird.
This is my Camelot number 5 that I stopped using after I thought the sling was getting scary and the trigger was broken. These larger cams actually are rated less, which makes sense because you have these big lobes torquing on the axle. There's the fear that they'll collapse. I believe this is the strongest way you can place these big cams. We call this umbrella placement, and it's basically a passive placement that you could do at the top of a crack, like a flake at the top of a crack. I don't see people placing stuff like this a lot, but you could do it.
I'm afraid it would move or fall off. Yeah.
Yeah.
Oh, Bobby shot at you.
Trying to take revenge.
Oh, it is the strongest. It ripped it out of the...
So you can see here they were starting to deform, and when you would actually place it, I think you would see failure a lot lower.
Oh, that is strong. All right, that's a great finale for our cams.